Hello, I think we can start. Hi. This third press conference of today is on soils and greenhouse gas emissions, and you have two speakers. One is Kovan Hoitston, an associate professor at the Department of Earth Sciences in Amsterdam, and Jorge Paz Ferreiro, if that's the correct pronunciation, a researcher at the Polytechnic University of Madrid in Spain. Thank you.
Hi, I am Ko van Huissteden. I'm working at the VU University in Amsterdam, the Netherlands, and I'm project leader of a Dutch, Russian, Japanese tundra research station in the northeastern part of Siberia. And that's the area where there's a lot of permafrost, a lot of ice, and a lot of carbon in the soils. I have a poster presentation in today, and also an extra oral presentation in room 23 at 15:30. So my subject is the so-called permafrost carbon feedback, and this is soil organic carbon, and which is vulnerable to permafrost degradation. This recent estimate estimates about 1,600 gigaton of organic carbon in high latitude soils, and that means 1 billion truckloads, or nearly twice the amount of carbon in the atmosphere. And it's very uncertain how much of that is going to enter the atmosphere when the permafrost melts. The IPCC didn't account for it because of its large uncertainty. There's some estimates that may be some 10% at the end of the atmosphere, enhancing the greenhouse effect. My main message of this talk, the talk that I was giving, is in the poster, that the global models that we have, they don't account properly for the degradation of ice-rich permafrost, which results in an underestimation of the amount of carbon that is lost to the atmosphere. And the other hand is also, when you have permafrost degradation, vegetation is going to occupy these places again, and you would have a greenhouse gas sink again by revegetation. That results in an overestimation of the permafrost carbon feedback if you don't account for that. So you need better models of permafrost degradation, in particular the ecosystem recovery after permafrost degradation is very, very crucial. What happens in models is that they gradually let the active layer or the top thawing layer of the soil thicken. But in real life, what you see is that you have ice-rich permafrost that may have some 80% of ice, and that causes a lot of different processes. Uneven thawing, you see ponds, lakes, and they have large carbon dioxide and methane emissions. And this may happen at all temperatures, actually, down to minus 20 degrees. So permafrost degradation is not just occurring in the south, but also in the high north. And that's triggered by climate change, but also by vegetation disturbance by humans, because the vegetation more or less protects the permafrost soils from thawing. What we see at our tundra research station is this. We see a lot of ponds. Actually, the number of ponds has increased by 3 times in 30 years, so that's quite a lot. As determined from different ages of satellite pictures. But on the other hand, we see also ponds disappearing, and that's because they have been revegetated. You see sedges immigrating these ponds, in particular on the right part of this picture, you see it quite well. And then what happens if you measure the greenhouse gas emissions from these ponds? As long as the pond is active, you have very high carbon dioxide and methane emissions. But if the vegetation invades it again, you have a much stronger carbon dioxide uptake by the vegetation, which nearly or completely compensates for the methane emission. And finally resulting, if the ponds close, you may have end up in a neutral situation or even a sink of greenhouse gases. That's what we see at our site, for instance. Now, if you convert this into a small model, and if you have different scenarios of vegetation, restoration, and different scenarios of decrease of the greenhouse gas emission, and you model this over time, you see very large differences depending on what kind of, that's the picture you see on the right. You see very large differences depending on the scenario you have for vegetation recovery. If you have no vegetation recovery at all, you end up with a very high emission at the end of the century. But if you have some vegetation recovery, after some time, you have much lower emissions, and it depends very strongly on the amount of time it takes, whether you have, at what kind of total emissions you end up. So ice-rich permafrost degradation is a big greenhouse gas source, but it's also a transient greenhouse gas source, and the evolution over time is very, very important. And if you don't model this, if you don't include this in models, as it's not included now, you cannot predict this permafrost carbon feedback with certainty. So that's my introduction for the subject.
So my presentation is about biochar potential to mitigate soil pollution and soil greenhouse emissions. So this is a talk I have been giving this morning, and it was mainly a review on the state of art of biochar research. So the main questions we would like to answer is biochar can alleviate the pressure we are exerting nowadays over Earth. Basically, we have a problem with climate change. We have also a problem of an overuse of nitrogen and phosphorus fertilizers, which result in eutrophication. And simultaneously, and in spite of the percentage of undernourished people that has been diminishing in the last years, the total number of undernourished people has been increasing as a consequence of the increasing population. What is biochar? Biochar is a mix of different charred materials, and it's created by the pyrolysis of biomass. This means heating biomass in the absence or under oxygen limitation, and it has a number of uses that are in this slide, but as a soil scientist, I'm more interested in its properties to improve soil. And with respect to greenhouse gas fluxes, it has been quite well established that biochar can reduce N2O emissions from soils. N2O emissions have 298 times the global warming potentials of CO2, so this is important, and this has been established both in laboratory and field experiments, although sometimes no changes have been reported. With respect to CO2 emissions, they are usually diminished by biochar use, although sometimes no changes are reported, and even sometimes biochar can increase CO2 emissions from soils. And with respect to methane emissions, the results so far have been much more mixed. So basically, the way biochar acts is like through pyrolysis. It creates a highly refractory carbon type material that becomes immobilized in the soil. So basically it's like moving carbon from a quick carbon cycle to a much slower carbon cycle. And well, different scientists have calculated different potentials to sequester carbon in soil using this technique. And depending if we choose to apply it only in croplands or if we also use temperate grasslands to store carbon. And well, it has been also been found that it retains, it absorbs heavy metals. So here there are some experiments that have shown that both the heavy metals bioavailable in soil and then the heavy metal that goes from soil to plant are diminished by biochar use. And even in this graph you can see that even if you stay many years without applying biochar, like after one single appliance and after several years, you still can find differences in heavy metal uptake by plants, in this case cadmium. And well, these are some of our data from Madrid. Here we had a controlled soil with low amounts of heavy metals, and then we applied seawatch sludge in 2 doses, and we applied a biochar that was made from this seawatch sludge. And we have seen that when we transform seawatch sludge to biochar, we obtain a product that is much more safer to apply to soil in terms of heavy metal pollution. And well, also experiments both in pots and in field have shown a potential of biochar to increase plant productivity. Like yesterday in the session I was the governor, there was a meta-analysis that showed that on average the productivity with biochar would be between 5 to 10%, although there are very high divergences depending on the type of soil and plant. And well, what it seems clear is that it's much better to use both fertilizer and biochar rather than biochar alone. And this is also some of our work in Madrid. We used an enzymatic soil quality index. Like enzymes are very sensitive to changes in management and to events like soil pollution. And we have seen that this index decreased in, it was the same experiment that 2 slides ago. So it decreases in soils amended with seawatch sludge, well, especially at a higher rate, but instead this index increases in soils amended with biochar. And well, there are still many questions open, as the interest of the scientific community in biochar is really quite recent. So some of the ones I can think is that could be unintended consequences over soil biodiversity, like maybe biochar can carry some toxic compounds, or they can modify the fauna of soils, and how the effect of biochar is obtained. Like Is it mostly a pH effect, as most biochars are alkaline and they have been applied mostly on acidic soil, or is there more than a pH effect? And also, well, of course, this would be like the key, like how to predict biochar effects on soil. Now, when we prepare a biochar and we apply it on soil, we don't know beforehand if the effects are going to be positive and how positive they are going to be. And finally, what are the long-term effects of applying biochar to soil? Well, this is everything. Thanks for your attention.
Thank you very much for two very interesting presentations. Are there any questions?
My name is Robin Webster. I write for the Carbon Brief. I had a question regarding your research on the recovery after melting from permafrost. It sounds to me like a very interesting result, but I don't have a good knowledge of the state of play, I suppose, in this area of research at the moment. Is this something that we're likely to see in the next IPCC report? I noticed from your update that you said that is not something that's currently included in IPCC models. And if it is, do you believe that your result is likely to have a significant impact on the kind of outputs from those models?
Well, there is some work being done in current global models using the vegetation, the increase of vegetation carbon uptake as a result of climate warming in the Arctic. So you would have more vegetation, more carbon uptake, and also by CO2 fertilization. But that's not really the thing that I was talking about. What I was talking about is the recovery after permafrost degradation, which seriously deteriorates the land cover, the vegetation land cover, and this is new, in fact, and it is hardly included in models. We have published in Nature Climate Change last year a model on tall lake expansion in the Arctic, which came out with quite a bit lower estimates of methane emission. I don't know if it's going to be included in the IPCC evaluation in the next one, but I guess it will. But the vegetation succession effect, which I mentioned here, we're just starting to explore it at least for our side, and I have not seen very much literature on that as yet. There's only one Canadian example that really comes close. Yeah.
I'm Jonathan Tyrone with Bloomberg News, and I recalled a few years ago the Arctic Climate Impact Assessment also did a study on permafrost degradation in the Arctic, and one of the observations it made was there was an impact on infrastructure, because infrastructure does exist. Yeah. And I'd be curious to see what your observations were to that extent. I mean, have you noticed any effects beyond the creation of ponds that you referenced?
Well, I'm working in a quite remote area where there is no, where there is not much infrastructure besides our own research station, and we have quite a lot of trouble with observation towers toppling when they are put on ice-rich permafrost. But I've seen in Yakutsk, and that's not really my research, but in Yakutsk, where our Russian counterpart is based, there's a lot of soil erosion, having big results on roads. There's pond and tall lake expansion in the outskirts of the city, etc. And also in the area where we work, there's people notice expansion of lakes, which mainly has effect on wildlife in this case. But it's really a problem. And in particular, if you are in areas where you have also hydrocarbon exploration, there may be strong effects, and there's also because of your disturbing the vegetation, which also protects the permafrost, you may have quite strong exacerbation of the permafrost degradation effects.
Anything from the web? No questions? Okay, if there are no more questions, I would just thank the speakers again. Thank you all for coming. I have 2 announcements to make. The 4th press conference of the day is at 3. It's on mitigating tsunami risk with early warning systems. And just before that, at 1:30, in room 20, there's a great debate on a very topical issue, which is open access and the future of publishing. You might be interested in attending. Thank you. Thank you.